All right. Today is February the 11th in 2023, and my guest is Luke Iseman. Luke is the founder and CEO of Make Sunsets, which is creating stratospheric clouds to cool the planet. That sounds sci-fi, and you hear all about it today. We'll talk about Make Sunsets and use it as a segue to talk about geoengineering as a way to combat climate change. We'll talk a bit in the beginning about our priors about climate change and how to think about it. We'll talk about geoengineering, and we'll talk about the challenge of measuring sort of the impact of carbon on the climate, or generally about measuring things that we care about. Luke, welcome to the show.
Thanks for having me.
We're joined today by Eli Dourado, Senior Research Fellow at the Center for Growth and Opportunity at Utah State University, and a previous guest on this podcast. Eli is an expert on geoengineering and will help me ask better questions. Eli, welcome to the show.
Thanks for having me, Nicholas. It'll be fun to join you for this.
Luke, can you tell us a bit about your background? How did you end up doing what you do now?
Yeah, so I've started a couple different startups. The first one that did anything was at the opposite end of the spectrum from a venture funded thing. It was actually a fleet of bicycle taxis that I taught myself how to weld in order to build in Austin, Texas. And it started out with just one for me to use, and then grew over several years to this really fun lifestyle business where me and 20 of my friends could ride bicycles around downtown while, eating pizza and getting tips from tourists, and basically the best lifestyle business I can imagine. So that was fun for a while. Then I started a couple other companies, none of which were huge successes financially, but interesting learning experiences, almost always in hardware. I get really bored just sitting behind a screen, no matter how much leverage there is for software. And eventually ended up starting a company that went through Y Combinator. It was called Eden, and it was solar powered Wi-Fi connected gardening sensors. This grew out of my own inability to keep plants alive and desire to, if I couldn't learn how to do so, use some computers to help me do so. Learned a lot from that. Eventually spent a couple years building a home out of a shipping container in West Oakland and some big art for Burning Man. And then kind of got bored and just started volunteering for Y Combinator to help them better support hardware companies. That led to an actual job there as director of hardware. I played a small role in helping YC better support hardware companies. While I was there, we went from one or two hardware companies every other batch or so to actually it required some coaching of demo day investors to deal with the number of hardware companies we ended up with. We ended up at almost 25% of the batch when YC was much smaller. So it was about 25 to 35 companies doing hardware, and not just, another little widget. These were ambitious projects like supersonic aircraft, 3D printed rockets, two of my favorite companies that I got to learn from when I was there. Grass is always greener. So after not too long at YC, the venture capitalists always look like the cool guys, the ones having fun when you're an entrepreneur. But as soon as you're a VC, you're like, man, I want to start another company. So I left Y Combinator to start a company focused on building tiny homes out of shipping containers. Thought that I had some interesting ways to navigate regulations in California, specifically around factory built housing and getting a stamp of inspection at my factory rather than locally, which made sense. Company ultimately failed abysmally at raising money. And also I failed to take into account that when regulations represent something like 30 to 40% of your housing cost of construction for a backyard house, it's entirely irrational to put in anything other than the largest home that you can. So I learned over the course of a couple of years and $500,000 or so why everybody puts giant McMansions in their backyards in California. After that, spent a couple of years traveling, did, kind of like life goal checkbox, non-company things for a while. Was basically like semi-retired in Mexico, spearfishing almost every day. Built a solar-powered off-grid house and everything. And at the end of the day, I was getting kind of bored and really wanted to start something else, collaborate with smart people on an ambitious project that could be good for the world. And I made the mistake of reading Termination Shock by Neil Stephenson, in which a billionaire in Texas builds the biggest gun in the world to shoot sulfur dioxide, basically like glider bullets into the stratosphere. And I don't know the 20-syllable German word for it, but as I'm listening to this book, I'm just thinking to myself, man, this is going to be a rabbit hole that I fall down. This is going to eat up a lot of time. I'd read most of Neil's stuff and knew there would be a pretty sound scientific basis for it. And then I was right. I dug into the research around it and was astounded by the contrast between the potential power of solar radiation management, this idea of reflecting sunlight before it gets, reflecting sunlight broadly, the potential power of it and the lack of actual real world research. Plenty of modeling, well established, very mainstream institutions say this is, our highest confidence tool to combat global warming. And nobody was doing any field experiments at all. So I bought some balloons off Amazon. They're called weather balloons. They're about 5 feet in diameter. Found a tank of helium at a nearby welding distributor in Mexico and bought some sulfur from actually it was from Amazon as well. It's used for agriculture. Lit it on fire, captured some of the fumes to get sulfur dioxide, put it in the balloon. It was at most 1/20th of the amount of sulfur dioxide that a 747 outputs in a minute for my total balloon content. And amount of controversy per gram on those couple grams of sulfur dioxide has been quite high, to put it mildly.
Well, what could possibly be controversial about fixing the climate?
You would think so. People have at a high level, you would think so. And on a long enough time scale, I'm confident that logical and calm analysis will win. In the meantime, it is scary to think about putting things in the stratosphere. Like, I admit that. And you have to dig a little bit to understand how much of this same chemical we're already putting in the atmosphere and how, by any estimate, it's far more harmful in the atmosphere. So yeah, it requires some nuanced thinking to understand, or just a willingness to experiment. Either of those, like, you can just not think about it and be like, oh, this is a tiny experiment, it's fine. Or you can think deeply about it to understand the rationale and why it's not, in any way materially risky. That middle ground is where people get in some trouble.
Well, that's what we're here for, to do some of that nuanced thinking and learn more about the way you think in the process. To start off with, before we talk about geoengineering and your solution, what is the problem that we want to solve with those things, and how should we think about it? I'm asking this question this way for a reason. Like, to many audiences, it seems kind of obvious. We want to prevent climate change and save humanity. Otherwise, we're all gonna die, right? My audience has probably a bit more eclectic views. Some are not convinced that climate change is at least as big as a threat as Greta makes it to be. Authors such as Björn Lomborg, Michael Schellenberger, or Matt Ridley. Luke, can you state your priors about climate change? What's the right way to think about it?
I think the right way to think about it is to look at the data. And I think that many of the details of scope of role of different chemicals is not only debatable at the fringes, but like when you read the details of the mainstream estimates, there's actually quite a wide scope of variance. Like, the official UN IPCC estimate of warming per 1,000 gigatons of CO2. And it's a footnote in like a literal 2,000 page report. Took me forever to stay awake long enough reading it to find it. But there's a 3x difference in the mainstream estimate. The UN says that we have high confidence that for every 1,000 gigatons of CO2 released, the Earth will warm by between 0.2 and 0.6 C. So people are right, in my opinion, to understand that there is uncertainty around the exact magnitude of different impact of what is causing different impacts. How much is cyclical? How much is man-made? In my reading of the data, and I think most people's, there's little serious debate about whether we are breaking temperature records most years and whether atmospheric CO2 is at a higher level than it has been for 500,000 plus years. Given those two, and given the clear link between increased levels of CO2 and increases in temperature, to me, there's two things we can do about that. If we do decide it's something that we care about and, we see the effects around us and want to do something about it, we can either pursue removing CO2 or reducing CO2 via, natural bleed out of the system as it settles over time and reacts, which is quite slow, or we can pull CO2 directly from the air. Both of those, both decarbonization and greenhouse gas removal, like direct air capture specifically, I think are important technologies. They're going very, very, very slowly. We need to do them eventually. The other option we have, which is where I'm focused, it does nothing to solve the problem of levels of atmospheric CO2 or ocean acidification or any of the other important problems that we're facing. What it does is just focuses on the temperature element. And the temperature problem with CO2 is that it leads to more heat being trapped that reaches Earth from the sun being trapped in the atmosphere. So if we reduce how much sunlight reaches the atmosphere by, I think it's like 1.8%, we would offset all of the warming that we've created since the start of the industrial age. This is, if we were, a bit more advanced and coordinated as a civilization, a physicist will tell you, and I agree, that the technically right way to do this is probably tunable mirrors at the Lagrange point in space, right? So we can choose exactly how much at this point where gravity between Earth and the sun equals out. Just put something there, keep it there, and choose exactly how much sunlight hits us. We seem to not be able to avoid land wars in Europe as a species right now. So I'm not willing to wait for that level of coordination to occur. In the meantime, by far the most effective thing we can do is to mimic what volcanoes have done for hundreds of thousands of years and put really tiny particles that are reflective really high into the sky. And the effect of this is that some sunlight gets reflected by hitting these particles back into space. Some of the technical terms that people talk about are radiative forcing. This is measured in watts per square meter. Because we have positive radiative forcing, we have an increase in how many watts per square meter of sunlight that reach the Earth stay in the atmosphere. We need negative radiative forcing in the stratosphere to reduce, basically just to directly create a thermostat. We have a thermostat for the Earth via CO2 emissions. It's only a one-way one right now. We need a down button rather than just up.
Yeah. That was also my reading. I think it's widely shared beliefs that seem extremely likely to be correct, that that climate change is happening and that it's man-made to a significant and impactful degree. Two critiques I found a bit more like I didn't find two good answers on it, right? So one was the critique that you probably agree with, that the solutions we have right now to prevent or mitigate climate change are not very cost effective. Right now, we're spending billions, maybe trillions, and we're not making a big dent or causing a large impact, which is probably also why you do what you do. And the other one might be also interesting for the purposes of this debate. Like, do we know that more warming is causing a net negative impact? Right. And the argument is, well, not all warming is not bad everywhere to the same degree, right? So many people die from cooling as well. So some areas might be better for like agriculture or food production and others get worse. So how do we even know that there's a net negative effect from climate change to give us enough confidence to so drastically try to reduce that?
Yeah. So I'll address your first question about how ineffective from a short to medium term ROI perspective measures like direct air capture are. I totally agree. I want to be very clear that we as a species need to manage like if you zoom way out, and I'm copying this from Neil Stephenson, at some point we're building a Dyson sphere or something like it. We're harvesting all of the energy of our star, like any, advanced interplanetary civilization eventually is likely to do. A step towards that at some point, whether it's, in now or 100 years, is that of course we'll carefully manage the mix of gases and the temperature of any, ball of rock that we decide to call one of our Earths, right? Like this is an obvious thing that we'll have to do on Mars. It's not debatable that we, of course, will manage this mix of gases more responsibly than we historically had. The question to me is between now and getting there, how much needless harm we allow to occur, how many millions of people die, how many hundreds of thousands of species go extinct, and how much collapse and decrease of likelihood of ever getting there we're willing to put up with. Like you saw supply chains break a bit during COVID. For example, take the Pearl River Delta region of China, where like half or more of the world's electronics are manufactured. It's right in the name. It's a delta. Like you can't have that delta continue to exist if you have, several meters even of sea level rise. And that's far from an isolated example of the disruption that we'll see if we don't take immediate action to create cooling. In terms of how do we know, to your second question, how do we know that warming is bad? I mean, I guess like one could imagine some very narrowly defined, like if you are a person in a specific city in Russia and have looked at climate modeling and all you're worried about is agricultural viability in the 100 hectares that you're farming, there are some people who will, assuming that overall system disruption is not too severe, which is a very big and very questionable assumption. On that very narrow view, you can imagine climate change being better for some people. However, zooming out to any extent, one of the things that I particularly love in nature and is very relevant, because if we take actions that I'm advocating, we just might be able to save them, are coral reef. Like coral reefs, almost all of them, 95% plus, will die when the ocean finishes absorbing our current amount of warming. So there's a buffer from slowly diffusing into the ocean, plus a bit more. It's around 2°C of temperature gain from 1850 of ocean temperature before most corals will go extinct. And that isn't, just a nice thing to snorkel near. That's mass aquatic ecosystem collapse and all the food impacts and runway impacts that we're very much not sure about of that occurring. So I think people are right to point out that benefits and harms will exist and will be unevenly distributed. However, I personally don't think that's an excuse for inaction.
Eli, is there anything you'd like to add to that debate?
Well, no, I think it's very well stated. Yeah, I think it's like, I think there is, I would ask like one question, like if you had your finger on, were able to have their finger on the dial for the thermostat and like control the mix of gases, like what do you think is the right, like do you take the view that the right concentration of CO2 in the atmosphere is like 280 parts per million, which is the pre-industrial level, or like a lot of people are increasingly saying like, no, like 350 is like a safe level that would have some of the benefits of like better agricultural output, maybe, like remaining safe while maybe like having the right level. So like are you like a purist who thinks like, oh, we got to go back to the 280, or are you thinking more in terms of like, well, let's actually like crunch the numbers and see what's the highest output level?
Yeah, we need to gain the abilityist. I don't really care where we decide to set it.
Yeah.
I mean, within a pretty specific range. Like if personally, I mean, there's a startup, 99.99% likelihood it'll die in the next year. But like on the outsized chance that I end up scaling this, and like there is a path of scaling this, which would result in a private company, essentially, as terrifying as this is, having control of the global temperature. within a range. I mean, I'd start by cooling it off enough to, stop sea level rise, which would be a greater, my guesstimate is that we'd want to create more cooling for a decade or so to refreeze things that are melting. And then, have an intelligent, see exactly, we'd learn so much by doing this about about the degree of cooling that sulfur dioxide creates with injections at different locations and different amounts. And we'd also learn a lot about, like, that's an experiment that we haven't run. We haven't done higher CO2 levels, which actually boost in net plant productivity combined with radiative forcing. Like, yeah, I'm not a purist about it. I'm a long-term techno utopian. I think that this is a step towards us engineering our exact, who knows what it'll be, mix of gases.
Yeah, and I think that's also a good segue into the discussion that we had before, Eli, about sort of creating mastery, right? When it comes to energy and climate, like developing technology that allows us to more effectively, be the master of our own destiny, right? So in some ways we have, or what we don't do enough of is taking risks with some of these new technologies, right? So a lot of the current ideology around climate change is degrowth, which is one way to do it, but a way with very significant trade-offs, right? If we just grow less, sort of by using less energy or produce less energy, then we have the trade-off that many people will be trapped in poverty or not. We won't have economic growth, which then leads to all sorts of other downsides because we won't be able to effectively mitigate against the impacts of a changing climate or a changing world in general with less wealth to get population somewhere else, to build effective protection against rising sea levels or things like that. So we need geoengineering and we need new technology that are able to provide sort of abundant, more energy while cleaner. Can you talk a little bit about your work on geoengineering, Eli, to kind of put this debate in perspective?
Yeah, sure. So I have looked at like all aspects of energy technology, and also have done a pretty broad survey just for myself of all the geoengineering possibilities that we have. And sort of my takeaway is just there's a plethora of tools. Like there's just a ridiculous number of possible things that we could do if we weren't kind of sitting on the sidelines to really solve a lot of problems. From, I think, like, if you want to just take the albedo control bucket, right, which is what Luke is working on. I think that he's right. We could do this sort of atmospheric approach, which is great. We could do the Lagrange mirrors, which he referenced earlier, which would also be great. I think actually, like, surprisingly, like, just white paint is surprisingly effective if you look at like sort of the amount of reflectivity, like per square meter for like a 1% increase in albedo. It's and then run the numbers on, like, we could just paint a lot of stuff white and it would probably work. There's a whole nother approach, which is I think like sort of around like ocean deacidification, right? You put like sort of alkaline materials in the ocean, and directly maybe saving the coral reefs, but B, that absorbs CO2 out of the atmosphere and sort of creates a new equilibrium, and that could potentially be very cheap. And that also, like the sort of atmospheric sulfur dioxide approach, that also mimics some natural processes that we, are fairly well understood on a geological time frame, right? The ice ages came about because some alkaline materials were lifted up from the mantle through tectonic collisions, right? And and aside from that, and then there's also like more ecosystem engineering approaches, right? Like iron seeding, to if you can provide the limiting material for reproduction of phytoplankton or whatever part of the ecosystem you're targeting, you can maybe produce uh, algae that are capturing carbon, and they're also providing food for fish and so on, and basically bringing some dead zones of the oceans to life. And that's also very controversial. And a lot of this stuff is, it's probably not the uh, ocean alkalization approach. That is like would have some cost per ton that's pretty high, or not high, but not high relative to direct air capture, but high relative to like just a person could do it. A lot of this stuff is stuff that like a person or a company could do, sort of in the termination shock spirit. And so I think there's a lot of options here, and it's like society's going to have to like come to grips with the fact that like we actually like can solve this. It's not something where we need to like sit by and sort of like scold ourselves to death. And I think that there's actually like a little bit of fear in society that's not just fear of climate change, but like fear that we might be powerful enough as humans to do something about it. And I think that is that's also part of the motivation in sort of opposing these experiments.
That reminds me
Sure,
of
Luke, what
one
you've
of my
experienced from, so I've seen that from the scientists and academia are saying, oh, this isn't tested enough, and things like that. You shouldn't be experimenting with this. So what does that say, or what's been your interaction with the scientific community, and what does that say about the science and their approach and their attitude towards risk?
Yeah, I mean, I think we have very different attitudes towards risk and lenses through which we see the world. Like, I can imagine it might be fun to be a tenured professor from a like don't care about getting fired perspective, and like almost a universal, not almost, an actual universal basic income, at least for your little group of other tenured friends. Um, However, none of these are vacuums. Like, startups aren't vacuums. Academia is not a vacuum. They have funders. They have assumptions that they come to the table with, just like I do. They're very different assumptions, leading us to very different evaluations of risk. I think that there's some out of control, zooming out, not to get too political, but the lack of willingness to say that something is right or wrong on what I would broadly describe as the left versus the right, I think like has led to big problems, particularly in the US. And I think you see that in academia with a lack of willingness to boldly experiment, or to say, like, for example, with stratospheric aerosol injection, I would posit quite strongly that an honest reading of the data means that every year we're not injecting megatons of sulfur dioxide into the stratosphere is leading to preventable deaths and extinctions, many of them. And, I haven't heard someone in academia say that, not because it's wrong. If you ask them directly, would this save lives? Most of them, pretty much every professor I've spoken with prides himself on his intellectual honesty, and I really respect them for that. But there's a big difference between intellectual honesty and a willingness to speak out or like do things that need to be done, which is surprising. And like, there's a whole lot of talk and a whole lot of bias towards analysis versus action. One of our first funder put it well, that we need more of a bias to action in climate in general. And yeah, it's fascinating to me that I'm the first person, at least publicly, to acknowledge injecting aerosols into the stratosphere intentionally. That's crazy. Like, didn't raise any money at the time, wasn't an expensive experiment. Like, literally anyone with $1,000 in a bank account could have done that. Which isn't anyone. Clearly, like, that's a privileged thing to be able to do, but like, that no one had done that yet is wild. And that step one on ScopeX, the big Harvard experiment that's been delayed for years, was to get consensus from a bunch of different people. Like, if step one on any experiment in the world right now is to get consensus globally, then like, I hope there's a betting place where I can bet on the odds of that experiment working, because ain't going to happen.
Yeah, so maybe it would be good, Luke, if you talked about like the actual size of your experiment relative to like global sulfur dioxide emissions, right? Like in terms of, what comes out of volcanoes and airplanes and then how much are you putting up?
Yeah. So from a top-down perspective, if we put less than 20% of the sulfur dioxide that we're currently putting into the atmosphere, if we just moved 20% of that emissions into the stratosphere, temperatures would drop to approximately what they were in 1850. That's a big if, like that's moving
Yeah.
megatons, 10 to 20 about megatons of sulfur dioxide into the stratosphere. But like it's that soluble of a problem. We produce this substance because reality is comical. Pure sulfur is a byproduct of oil and gas refining. And then to go from sulfur to sulfur dioxide, you literally just can light sulfur on fire in the presence of adequate oxygen. So like in open air, sulfur will burn and produce sulfur dioxide. Modern 747s output about 100 grams of sulfur dioxide every minute. My biggest balloon that I've launched so far was maybe 2 to 5 at most grams of sulfur dioxide in total, not per minute, in total content. So like
Yeah.
the people debating, oh, and the balloons are biodegradable as well. They're latex. It's like 2 to 3 years it'll biodegrade. People debating that the experiments have had some actual impact in any meaningful way is it's just like not it's quantifiably wrong. And that has been a lot of the debate. Obviously, like there's a symbolism to it, and the propaganda of the deed matters, and the Overton window matters. But the quantities are so minuscule. And a lot of the debate around, helium scarce. Yeah, I get it. It probably doesn't make sense to use balloons, but walking before you run.
Hydrogen balloons, right?
Yeah, hydrogen, and we'd probably have to flare the hydrogen to avoid damage to, it's a greenhouse gas, but we'd either flare it or bring down as much of it as we can and flare a small amount. These are problems to solve later. You don't worry about your nutrition regimen for a 100K ultra marathon when you're taking your first steps. And like, this is more extreme of a divide than that.
Yeah. I think listeners would also like to understand like how effective like 1 gram of sulfur dioxide is. Like, do you have numbers for, what is the amount of warming abated by like 1 gram of sulfur dioxide?
Yeah. So just like with CO2, there's an uncertainty band here. And I went with roughly David Heath, the foremost academic in this field's numbers, which are his shorthand is that a gram offsets a ton for a year, meaning that 1 gram of sulfur or 2 grams of sulfur dioxide, if we're being extra conservative, delivered properly into the stratosphere, so 20 kilometers shorthand, in or near the tropics for optimal Brewer-Dobson circulation so that it stays in the sky for 2 to 3 years, offsets the warming effect roughly of 1 ton of CO2 for 1 year. And we say ton year because the lifetime of carbon dioxide in the atmosphere is much greater than, the 2 to 3 years that our particles are staying up there. That's been critiqued by some scientists. Honestly, I don't really care fundamentally whether that's exactly right. I think we explain why we're using that number, and we are more than willing to, if there is a better consensus estimate, use it. The lowest that I've realistically heard is 1/10 of that. Even if we're at 1/10 of that, a gram to a ton is 1,000,000 to 1 leverage, which is pretty amazing in my opinion. If we're only quote unquote 100,000 to 1, that math's still pretty compelling. And then your dominant cost when you're doing this at scale to think about is the bulk cost of sulfur, which is $200 a ton. So, there's delivery costs. Those will change whether we're using balloons or jets or whatever. But this is, put it this way, this is enough measure that the lead academic in the field is worried that a private company doing this will freeze the earth because it's so inexpensive and capitalism is so runaway that it would just lead to an ice age.
Yeah.
Which I find hilarious.
Yeah. And then do you think there's like headroom to get even more effective with different altitudes of release or different particles? Like it could
Absolutely.
like this is what do you think's the realm of the possible in terms of, after we do some experimentation, what do you think is possible?
I mean, it's me and one other person, and then I talked to a bunch of interested observers about this, and already we've identified a molecule that is inexpensive, forms nanoparticles readily, and is very unreactive. So like, I'm intimidated by that because of the potential lifetime of it. Like that's going to stay up a lot more than 2 years. And that people are writing this off, that many academics are like, oh, you're going to ruin the world by doing small releases and then doing giant releases of exactly the same particle of exactly the same efficacy. It's just, I mean, it's, to me, from the startup world, like you're attacking a minimum viable product as if it's a thing on the shelves of stores everywhere at scale, right? Like it helps explain why there isn't more innovation. At least to me, it helps explain why there's not more innovation in academia.
Yeah.
Yeah. I'm wondering, or that's kind of one theory that came up with on the fly. The academics, they want to be the gatekeepers, right? So they're saying, oh, you should get like the consensus from the scientific community or from like the regulators or whatever. But I think there's like this tension, right? Because when we're in startups, that's not how you get to figure out what new technologies can work or can scale, right? So we have something called the technology adoption lifecycle, right? So we start off like with the radicals, the early innovators, and like the true believers and the hobbyists. And then only gradually, once things are kicked out, we scale up to more mainstream audiences, right? To early adopters, to the early majority, to the late majority, right? So if any new, and that's how almost any new technology gets adopted, like crypto, the internet, anything. So if we put any new technology kind of to that democracy or consensus test, like 51% of the people need to agree, or like, the scientists need to agree, or the regulator, then we're not going to get anything new, right?
I think that's a great reminder of, this makes me think of the innovator's dilemma. Christensen's work that, thing even more intricately, it's that things are bad on new innovations are bad on almost every scale, except for one that some weirdos care about. And then innovations that scale happen to have been better on that one thing that a growing group of weirdos care about and are willing to eventually pay a premium. Like one of his examples is the switch from normal mainframe hard drives to things that are more portable. It was like dramatically more expensive. The only thing was that they were smaller and actually portable, dramatically more expensive per megabyte, and made zero sense for existing drive manufacturers to create, because they're like, why would we make this shitty thing that just happens to be portable? Nobody's going to buy these. But a small and growing number of enthusiasts were like, we need a drive that we can move around. Yeah, I think that almost with clean tech, there's like this lack of discipline that occurs with otherwise quite impressive founders and investors. Had a very enthusiastic and borderline, we weren't shouting, but we weren't totally calm, argument quite early in this process with one of, if not the leading, investor in early clean tech stuff. And he was very enthusiastically telling me that I needed some type of political consensus before I could even think about developing something like this. And finally, I just go, dude, can you name one innovation ever that has occurred after careful debate and universal consensus before people started working on it? And like many examples of the opposite, this was on the tail end of COVID. The most vivid to me is the smallpox vaccine, which is crazy doctors in the country putting on, like, scraping things off of cows that represent cowpox and putting them on people, of questionable radicalism for the time, let alone now. But yeah, that's how we tend to be weirdos experimenting to develop new things.
Yeah, and I would say like there's a confusion about like the end state versus how we start, right? Like in the I think if kind of the conclusion is like ultimately we're going to gain complete control of Earth's thermostat, and we do want to have some like consensus driven like global process for like controlling that. Like I think that's like fine. The issue is like the consensus political system is not doing that, right? They are just like sort of sitting on their hands and they're not doing it. And you can't, it doesn't make sense to wait forever for that process to move um if it's not likely. So I think it's like unsurprising to me that we're in this place where um you're doing it to show that it can be done, and like maybe there will be a way that gets transitioned to like a global decision making mechanism, but the global decision making mechanism is not the innovator that is going to prove that it works, or fix the most severe aspect of the problem.
Yeah,
Yeah,
there's
and
like a
then like
fundamental mismatch, right? One decision mechanism doesn't get you the kinds of decisions you need to make to innovate, right? There's this fundamental tension between sort of consensus-based decision making and how any new technology develops.
yeah, and even I mean to attack consensus a bit more, like I I don't think that moral progress comes from consensus. Like if you took a poll of people and asked them at any point in the past, like, I'm in the US right now. If you did a poll in the South and we're looking for a majority to decide whether slavery was morally permissible or not, you don't get moral progress by looking for consensus. You get moral progress by pushing at the edges.
Yeah. So with a minority that really cares about the issue and then, starts by building something that eventually becomes a better product that eventually other people can agree on or buy into, because they see that so many others are already using it and that it is the better thing. And then it kind of becomes the new consensus by starting at the margins, and then with added like safety features, with added experience, with an added kind of becoming a social meme that it grows, right?
Yeah, I think that's a
So
great way
how
to put it.
could, um, yeah. So what would be the pathway for you, for geoengineering, for make sunsets, for, using stratospheric clouds to get to mainstream adoption? What's the pathway? What needs to happen?
Yeah, so for the first 3 months, we just incorporated at the start of October. So this is moving nice and quickly. I wish it was even faster, but it seems to be making most in the field uncomfortable with its speed, which I'll take as a sign that it's maybe not moving quite as slowly as I feel like it is sometimes. But first 3 months, my co-founder's focused on sales. I'm focused on tech and basically everything else. And he focused on trying to get companies to adopt this via, some of their spend on ESG broadly. And we made up a concept of a cooling credits that one might imagine a world in which instead of buying fake forestry credits for $50 a ton, companies instead do a bundle of our measure, which were very profitable at $1 per ton year equivalent, coupled with far more expensive direct air capture to achieve a blended cost of carbon, temperature mitigation plus long-term carbon removal measures that is comparable or even better than these largely fake forestry credits. That failed. No companies, our first two investors agreed to monthly subscriptions, a couple $100 each, kind of because like I made it a condition of the deal, to be honest. But no other companies have adopted it. However, in the meantime, trying to move as quickly as possible, we put up a quite minimalist Shopify store. And as of today, we have, I think, 48 people, no companies, 48 individuals who have bought cooling credits, one or more each. Our biggest order was somebody bought $1,000 worth. And one, we're super flattered by that. Two, it feels a lot like we're starting to get our crazy enthusiast early adopters. And three, in spite of like, having worked as a venture capitalists with early stage companies, I try a lot, maybe even too much, to like pattern match for myself and be like, okay, are there things that I think I'm an exception to the rule about? And if there's more than one or two, then I'm probably, smoking my own supply. Like I'm probably wrong. I'm probably missing something fundamental in probably, but not definitely. And I bring this up because like this idea of doing direct to consumer climate thing as a startup, nobody's done that successfully. There are people trying and it's not going well, to put it mildly. But I should be cognizant that we're calling ourselves the exception to the rule in a lot of different overlapping ways and that it's incredibly unlikely that I'm right. But also it's a possibility that we're right. So what we're focused on now is growing that this month to 100 plus crazy enthusiast early adopters who are willing to put at least $10 towards pulling credits. And then over the next 3 months, we'll try hard to grow that to 1,000. And there's kind of three fundamental potential customers: governments, these individuals, and it's an interplay between them. Those are ranked in terms of like their ability to just write one check that literally at least stops making this problem worse. Like it's about $30 million to make the world slightly cooler next year versus this year. So to more than offset our current new increase in warming that'll occur next year. And, I want to not have religion about who our customers are or in which order those three parties become enthusiastic customers of ours. All three of them should be eventually. And, if we have to build this army of 1,000 and then 10,000 true believers who then pressure the brands that they care about to stop buying bullshit fake forestry credits and instead invest in direct air capture and our technology, like that's the current plan. All of this is super unlikely, but we've got some early adoption, which is super exciting to see.
Yeah. So that touches on another innovation that's part of your company too, which is cooling credits. Can you talk a bit more about the problem with what you call fake forestry credits and current ways how we measure? Like it goes to also to carbon exchanges and carbon credits.
So basically, initially, when I was thinking about starting this company, I was like, these voluntary carbon credit things just seem like a weird snake oily market, and I don't want to touch it at all. And then several friends with companies who buy voluntary carbon credits encouraged me to rethink that. What really put me over the top was when I spoke to a friend at a giant manufacturer, giant Taiwanese/Chinese manufacturer. He mentioned that they had a net zero plan. And this isn't like a little US marketing company. This is a giant Asian manufacturer that makes and sticks to multi-decade plans. I was one, stunned by that. And two, as I dug deeper, I became more convinced that the supply side of voluntary carbon credits is either scammy or expensive. If it's over $100 per ton, it's very likely to be at least somewhat real. If it's direct air capture, it's less than $1,000 per ton, it's almost definitely still losing money. So like buy it, but be wary that it needs to keep raising venture capital to continue doing that. Almost definitely. And if it's cheap, it's almost definitely a scam because, and I'll say that more assertively than I would have a month ago, a big study by The Guardian just came out about Verra, which is the biggest blessor of these. They call it an accreditor. So they do monitoring, reporting, and verification that when somebody says they're planting a tree, they actually do blah, 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 or at least they're supposed to. The Guardian's estimate is that 90% of Verra, which is 65% of all of the voluntary carbon credits that are blessed. So 90% of those, by The Guardian's estimate, are literally non-existent. Companies have spent tens, if not hundreds of millions of dollars to buy not even snake oil. Like there's not even any snake oil to it. It's literally just an empty promise that doesn't exist. So that's frustrating to see. And by the way, Verra, Puro is the newest of what I would call the three majors. There's Verra, Gold Standard, and Puro. Puro is different. So they do not charge a fee to the company, and they appear to, we haven't gotten through the process with any of these, but they appear to move substantially faster and overall be better, in my opinion, than Verra or Gold Standard. But Verra won't touch us. We tried, they do carbon equivalents for things as exotic as like adding an incremental EV charging station gets you some number of blessed carbon credits in the voluntary carbon market. Vera won't touch us. They deign not to work with us. They're too prestigious. This thing that is, certifying 90% fake credits. And gold standard, slowly we might be able to go through a part of a loophole of the process. Even with that though, like at minimum, it'll be 1.5 to 2 years to go through the process of getting blessed by gold standard credits. It'll cost well over $100,000 plus, 30 to 50 plus to pay a consultant who's gone through the process before. And then the real kicker is that my biggest cost per ton of CO2 equivalent will be paying the commission per ton to gold standard. So like, I don't know. I'm of two minds about it. I've had a couple potential corporate customers tell me that if I get accreditation by one of these major three, they'll buy credits. But, we've raised $750,000. This is obviously controversial. I don't want to ever assume that we'll ever raise any more. And like to put a third of that towards going through this of questionable quality process, like strikes me as maybe not the best decision. So we've entered the first phase and I've spent a bit, like well under 1/10 of that towards it. My real hope is that a market for albedo enhancement occurs where there are different reflectivity technologies. On the decentralized and DeSci side of this, you might recall I mentioned MRV, monitoring, reporting, and verification. Those are the 3 functions that people talk about for voluntary carbon credits. With something like reflectivity at scale large enough that it's visible from satellites or, balloons or planes, one might imagine a market that is decentralized where all 3 of those, where the monitoring, the reporting, and the verification are actually built into the technology, because at a large enough scale, even with white roofs, for example, you can see these from space. So not only can you verify that it occurred, if it's large enough, you can verify that it's continuing to occur and issue these imaginary reflectivity or cooling credits on an ongoing basis via something decentralized, and not deal with the delays and the high cost and the questionable quality of these centralized blessors of carbon credits. Yeah.
What are you thinking about in terms of your own validation of the effect of the release of these particles? So let's say you had what you think you said $30 million to offset this year's warming. So if you had $30 million and you did it, like there is like some variation, naturally in temperature from year to year. So how are you thinking about in terms of, proving that it had the effect that we pretty much know from theory that it will have, but exactly measuring it or pinning it down? How are you thinking about that?
Yeah, you raise a good point. I've been reading that we may actually break 1.5C either this year or next, depending on El Nino. Like it's like a 0.1 or 0.2C potential, but not certain boost. So yeah, really like one, this would be very visible. This would very likely be visible from many satellites to do at this scale. 2, still some people wouldn't believe it. So ideally we do double the next year and then nothing, and then triple the next year. And then like you do oscillations. I mean, until people are convinced enough, or enough people are convinced that we can afford to continue to do it. Like, not to joke about that, but kind of to joke about it. Like if it's within the scope of an El Nino effect, I'm sure. And by the way, all weather is automatically my fault already, right? Like these couple grams, anyone can blame me for anything, let alone with scale up, like the monsoon, simultaneously ruining the monsoon season and making it too severe, and drought and flooding. Like those are all anybody's fault who dares to do anything like this, of course.
Yeah. So oscillating the sort of the input, right? Like doing a big release and then not doing some for a while, and then showing that the variations like in temperature line up and what the correlations are. Like,
worst case,
or
that's
basically the answer.
Or much more desirable would we just do more and more every year. And it's like, okay, we're not sure if it was slightly colder this year because of the sulfur dioxide, okay, again, it was slightly colder this year. It's starting to look like it was that sulfur dioxide, and it was slightly colder this third year. And it's, we could, instead of turning on and off entirely, we could amplify, and we could amplify at different rates, right? Like at some point when you call your shot, when you say we're doing double this year and it's going to be an additional, 0.05 C on average colder this year, plus or minus 0.2 C or whatever the uncertainty is. At some, still some people won't believe it, but that's fine. At some point, people are like, okay, now we actually have control of our climate. Which is, to be clear, like the amount of money we're talking about for this and the time scale is so insanely small. Like, whether or not you agree with my approach, I hope this makes people listening a bit optimistic about whether we choose to use it or not, our potential power to do something about this. Because almost all climate news is just doom and gloom. And it is bad news, but we do have this and other tools to radically improve the condition of our world.
Right. I love that. As a conclusion from this conversation, like we have the technology to radically improve our world, right? I think we learned we got a very great story how we're sort of shooting ourselves in the own foot by using the wrong approach to new technology to, experiment in the real world to actually do it, right? And I think that's what we have today is a good example. I think it seems there's still many things we need to figure out, but we need to start somewhere, right? Well, we have a lot of things we need to improve on. The way we do the measurement right now of the impact that we have on the climate, the way we can sort of offset it is a market that you just talked about where you have fake credits and a lot of people fall for that. Seems to me also like a use case for blockchain technology where you could have many of these measurements open source and agreed on through an oracle. So there's lots we need to work on. Anything else that we haven't talked about yet in the context that you feel like is important to give listeners on the way that they can maybe work about or start thinking about their own lives? I know there's many entrepreneurs in my audience who are listening and who want to know what do we need to figure out? What do we need to work on?
I want to make it clear that, like, while there are challenges, some of which we haven't talked about and some new ones, legally and otherwise with this, it is very satisfying to work as an entrepreneur on a problem that, high consequence, low probability, but could be really, really important for the world. And I think entrepreneurs hearing about the challenges with this, like, I hope that they are encouraged, not discouraged, because this is super fun in spite of the challenges. Like, I'd rather be doing this than printing money with some new cryptocurrency by far. And secondly, I want to encourage just broadly people not to only think about this economically, but also like think about if you can get together a band of true believers for whatever it is that you're working on, like $1 is not $1. If you can get 1,000 people who you're super excited to be around, whether it's, forming your new semi-autonomous country or treating it as a moral obligation to to get as much of some chemical into the stratosphere as you can, like $1 is not $1. You can, working with very smart people in small to large bands of them is way more satisfying and can have way more impact than, things that make way more money, but keep you stuck not doing something more ambitious.
Right. I love that. Eli, anything else? Any concluding thoughts?
Yeah. I mean, it just seems like this is what I feel like we need more of in the world, right? We need more people, like the bias for action. I think there's so many problems. It's not just climate, but we've made it so hard to do things in the physical world based on, a lack of, innumeracy, frankly, in this case, right? Like, it's just a lack of understanding of what the effects are, right? And you could point to, I'm not a big nuclear person, but nuclear power is like a perfect example. Like we've made it. People have like such irrational fears of it, and we need people to just can go out and do it.
Great. Luke, it was really epic to have you on the show. Is there anything else that any support that you want to enlist right now from listeners? Who should approach you? Like either that you think for more investment or you're looking to hire people, what partners or collaborators should come to you and how can they find you?
Yeah, I'm super easy to find. Luke at makesunsets.com or Luke at lukeisman.com. And most helpful would be if you are in a country and have a group of friends who want to launch a balloon. Like we need launch partners. We need places that want to have us there. Mexico was not that. Second most helpful would be if you work somewhere that buys carbon credits. And like probably the question to start with is, can I self-direct our spend on offsetting our footprint? Like I'd love to hear what people's companies say about that. And then also just broadly, like clearly this is not primarily about making a quick buck for me. I care about this field. If you're starting something ambitious around technology, I'm happy to give as time is available, I'm happy to give, especially if it's if people send me a specific question about a barrier to working on their MVP, I'll almost definitely answer it. And like sometimes I have a unique perspective there.
Awesome. Luke and Eli, thanks so much for coming on the show.
Thanks for having us.
Great to be here.